you have learned every single one of these steps, but we've done it all separately. So now we're going to put it all together to get a nice, very accurate curve, okay, or graph. So what are the steps for curve sketching? And yes, this is the order that I would like them in. So step one are your intercepts. So you're setting in 0 for x or y. That's to find your intercept. Number two, asymptotes and holes. So for this, we're going to need to factor and simplify. Look at the denominator, set it equal to 0, and take the limit, and that's supposed to be under horizontal asymptotes if defined. Then you find your critical point. Now, first derivative test. You don't have to do the first derivative table. That is optional. You could choose to do your second derivative table. So you're doing one or the other, not both. You're either doing this table or this table. You're not doing both. Okay? The choice is yours. What does that do? It tells us whether it's a match or a min. Right? That's what we're trying to find out here. To find if it's a match or a min. All right. Then you're going to find, hold on. Your second derivative or this. This is the same, yes? When you're using your second derivative now, we're going to set it equal to 0 to find your point of inflection. And then here is your second derivative table, which is being used to check if it's actually an inflection point. So this is your second derivative. So one or the other, not both. Okay? The second derivative table, yes, you're going to do it because if you come out with a point that is a potential, a possible inflection point, you have to test it to check if it's actually a point of inflection. All right. From the point of inflection, from the second derivative, we check concavity. Okay? And again, that also tells us field value, right? Which is maxes and mins. Lastly, end behavior. Okay, what's happening as x gets really, really big? What's happening as x gets really, really small? And lastly, depth. You're going to notice that I just added in end behavior because it's not always necessary, but it's a good habit to have. Okay, so I've added that in, end behavior. So these are all the steps required when you're sketching a curve. Okay, yes. Yes, right. No, so this is going to tell us where it changes from a max to a min, what that point of inflection is, where we're changing from concave up to concave down. End behavior. If you're looking for absolute, then you have to look at the end behavior. But we don't really think whether it's an absolute, not feminine. Right? We don't care. Yeah, no, we don't care. As long as you know what the end behavior is, and as long as you know what the local max is in the variable. Now you don't have to state, oh, this is a local max, oh, this is an absolute max. You don't have to state that. Okay? Good. Are there any questions? Note, behavior and increasing, decreasing intervals are essentially revealed in the second derivative table. Therefore, end behavior and the first derivative table are not absolutely necessary in your solution. So that's why I had never included end behavior before, but I have included it now, so I would like to see it. Okay, your end behavior. All right? Good. Okay, first graph. So we want to sketch this. So this is generally not so bad because it doesn't have a denominator, so you know you're not dealing with asymptotes, right? No asymptotes here, so it's going to be a little bit more simple. Very simple polynomial, the derivative won't be hard to find. So let's start easy. We're going to start with our intercept. So I'll start with the next intercept. So for me to find the x-intercept, I know that I have to let y equals 0. Good. So what do I need to do? If I'm going to let this equal 0, what do I need to do? Yeah, we want to factor it. So what can I factor in? X how many? Good. And so now this is showing me what? What are my two values? Good. So we've got x equals 0 and 4. Right? Oh my God. We said 0. Didn't I say 0? I said 0. Okay. All right. So now we've got 0, 0. I got 2 points out of this. Okay? Here are my two values. Now we're going to find the y-intercept. We let x equal 0, and so we just have to sub in. And as we expected, we got 0, 0 again. No surprise here because it came out in the first one, right? All right, so I've got 2 points. So you can at this point go ahead and put them on. And we'll have our intersection. Good. Okay, the next step is asymptotes, but it's not a rational expression, so I don't have to worry about asymptotes. We say no. Step 3 now is our critical point. So that means I got to find my first derivative. So what's the first derivative here? Nice and simple. So there's my first derivative, and now what do? Yeah, I said it goes to your own solve. So in order for me to solve for this, guys, what do I need to do? And I'm left with? Okay, so I have 2 critical points here. My 2 critical points are? Good. And now go ahead and find the y-coordinate. We might as well. We're going to have to drop them, right? So go ahead and sub in and find the y-coordinate. So 3 comma.
Negative 27.
Yes, thank you. 3 comma negative 27. Perfect. Okay. Next, what am I going to do? At this point, I could do. Yeah, sorry, go ahead.
I was going to say plot the points. Plot the point.
Yeah. We already have 0, 0. And then I have 3 negative 27. Let's do it. All right. So now we have a choice. We could do our first derivative table, or we could wait to do it with the second derivative. What do you guys want to do? Do you want to do the first derivative plus now, or do you want to try using the second derivative plus? Sorry?
Second derivative.
Okay, I've got 2 people saying second and 2 people doing first. I need to tiebreakers. Candy, what do you think? First or second? Okay, we're going to do seconds for this one. We'll do first for another one so you guys can see the difference, okay? So here, now I'm going to wait to find out if their math is in the second derivative test. So what am I going to do next? Well, I'm going to find my derivative, my second derivative. So second derivative, guys, what is it? And we set it equal to 0, and we factor. So when we factor, what are we left with? Oh, sorry. Yeah. Okay, so when we factor, what are we left with? Good. And so here I have x equals 0, x equals 2. These are my possible points of inflection, right? Okay, now I want to do my second derivative test. So I'm trying to find out whether it's a max or a min. Who remembers what to do? Who remembers what to do?
We should plug in the critical points into the second, into y double prime.
Excellent. So the first critical point was 0. And so you're going to sub that into y double prime, and you're going to see what happens. So if I sub in 0, what happens? Uh-oh, what does that mean? It means it's not a max or a min. That's okay. And then we're going to test 3. What do we get here? Obviously, is this a positive or a negative number, guys? What is it? Positive or negative number?
Positive. We get 36.
Excellent. And so because it's a positive number, we know that it's a minimum, right? And the point was 3 comma negative 27. Okay, good. So we now know that that value is a minimum. Now we have to check concavity. So we're going to do our second derivative table. And here are the values that I'm checking. And my factors were 12x, x minus 2. And we want to know if it's positive or negative in the end. Okay, so to the left of 0, looking at 12x, positive or negative? Negative. And x minus 2 to the left of 0? Negative.
Negative.
Excellent. Okay. So here we're concave up. Okay. All right. Next. Between 0 and 2. Positive or negative?
Positive.
Yeah, thank you. And then here, positive or negative?
Negative.
Okay, and here, positive, positive. Yes, let's just do that. All right, so this is showing my concavity. So here we're seeing that we are concave up, less than 0, greater than 2. Concave down, in between 0 and 2. Okay? So what can I conclude then? Do I have any points of inflection?
0 and 2.
Yeah, I have 2, don't I? Because the concavity is changing, I know that I have 2 points of inflection. So therefore, I have points of inflection at x equals 0, or let's just put it in 0, 0, and 2 comma, sub it in, what's the value?
Negative 16.
All right, so let's put these points on now. So 0, 0 I have, and let's put in 2 negative 16. There we go. Okay. The last thing that we should do is just look at the end behaviors. So to analyze our end behaviors here. I don't have any asymptotes. So I don't have to worry about crossing of asymptotes. But when I sub in a very, very, very big value of x, what do we know is happening to this function? As I sub in a big value of x, what should be happening to this function? Is y getting bigger?
Positive infinity.
Yes, good. So as x approaches positive infinity, so does y. And as x approaches negative infinity, what's y doing?
Positive infinity.
Yes, it is also approaching positive. Okay, so let's graph this. I think I have all my points. Have I put everything in? How do I know? It's as simple as get to get 100, plug it in and see. And you in the positive, you in the negative. That's simple as that. It's a little place. Okay, and this is why, you see in this case how a case like this and behavior really isn't that necessary. That's why we haven't always included it, right? Because it's not always necessary, but sometimes it is. Okay, so we're gonna graph this now. Now, I know that I have a point of inflection. Okay, let's start with the minimum. How about that? So I had a minimum here, yes? So that means something like this. Not gonna make it. Okay, so that's good. And we're all concave up, right? We said we're concave up for this interval. Good. I have a change now. I have a point of inflection here, which means here I need to be concave down, and then here I need to be concave up. So it's going to be like this. You see that? Okay, so we're changing concavity here. I'm sorry it didn't go straight right to you guys. It's hard on the smartboard to get it exact. And then here. Okay? Any questions? No, absolutely not. But that is an absolute, right?
When would a possible POI not be a POI? I mean, like in the example, I know it's not when the concavity just stays the same, but how would it look in the graph?
I don't know. Let me think about it and I'll try to think of one for you. Okay, I can't think of one off the top of my head right now. But I'll think about it and I'll show you one, okay?
Oh, wait, thanks.
Yeah, no problem. I'm just trying to think. Didn't we say it yesterday? We saw it in the lesson yesterday, didn't we? Well, if you wait till after the lesson, I'll go back. I think we saw it in yesterday's example. I'll look again. I'm pretty sure we did. Okay, example 2. Sketch y equals 1 over x squared minus 1. So, actually, excuse me, I have a different one. So y equals x plus 1 over x plus 3 all squared. Give me a sec. Why do I not have it? There we are. Okay, so one thing that I want to point out from the other example, which we didn't do, we didn't state our hills and valleys. So I did say where it was concave up and concave down. What I should have done here was stated my hills and valleys. I want to put that in because I want to make sure that you guys know to do it. So here, I have a hill. I have a valley. Cool? So just make sure that you put this in. Okay. Next example. So y equals x plus 1 all over x plus 3 all squared. So what's the first thing we do? Step 1. Yep. Oh, did you say asymptote or intercept? Intercept. No, first one should be intercept. Why did you say asymptote? You know what, guys, my questions sometimes are full. I'll fix it. Number 1 should be intercept, not asymptote. Intercept. Always intercept. Does it really matter now? Okay, so finding an x-intercept, we know that we let y equal 0. Huh? Oh, you're giving me the answer. Yes, sorry, I thought you were saying it should be x minus. You're absolutely right, Esther. So what else am I saying? Okay. You only have to worry about the numerator here because the denominator, as long as it's a number, it doesn't matter. 0 divided by a number is 0. So yes, you can see that x equals -1. And so from here, we're seeing the point -1 comma 0. And then we're going to find the y-intercept. And then let x equal 0. And I get 1 over 9. Okay, so we can go ahead and graph this if you like. We can put these in. So I've got -1, 0. And then I have 0, 1 over 9. Well, what's 1 over 9 as a decimal? Yes, excellent, 0.111. So we're just gonna estimate it. It's gonna be very close. Okay, now step 2, we want to find the asymptote. So, and here I know to check because it's a rational expression, right? Instead of rational function. Okay, so for the vertical asymptote, I look at the denominator. What will make this denominator equal to 0? So I have a vertical asymptote at x equals -3. Let's put it in. Okay. Remember to always label it, okay, guys? All right, for our horizontal asymptote, we have to find the limit. As x approaches what? Good, infinity. Of our function, which is... Okay, who remembers what to do? Who remembers what to do?
Expand.
Okay, yes, good. We're going to have to expand it. Why? What do we need to do?
Because we have to divide by the highest degree exponent.
Beautiful. I have to divide every single term by the highest exponent of x. So I need to expand this denominator, and it will give me x squared plus, yeah, beautiful. Now, I divide by the highest exponent of x, which is and even if I don't simplify it, you guys should be able to see what's happening in my numerator. Here I'm going to have 1 over x. So 1 divided, yeah, so it goes to 0. This is definitely going to approach 0. This will just be 1. And this will approach 0. So I have 0 over 1. Which is just 0, right? It's a constant. So we know when you take the limit, it's just 0. Therefore, horizontal asymptote. Put it in. And we must wait. Yay. So we have our nice. Okay, what's next? Step 3. I want to find the critical point. Okay, here, I'll leave it. All right, critical point. So that means I need the first derivative. It is a quotient rule. Who's going to do it for me?
X plus 3 all squared times 1 minus x plus 1 times 2 times x plus 3 to the power of 1
Good.
all over x plus 3 squared all squared.
Squared all squared, so it's to the exponent.
4.
Yeah. Okay, let's clean this up. How do you guys want to clean this up? What do you want?
Factor x plus 3.
Excellent, good. You should notice that there is a common factor. I can only take a 1. And then what am I left with? Yeah. Yeah. Beautiful. And now I use my exponent laws to see that my denominator becomes x plus 3 to the 3. And in my numerator, I've got x plus 3 minus 2x minus 2. What does it clean up to? Negative x, and then
Plus 1.
Yeah, thank you. Okay, so now we set this equal to 0. And I only care about the numerator, so 0 equals negative x plus 1, and so x equals 1. This is either a max or a min potential. Yes? Yes. So this is my critical point. When I sub in 1, guys, what's the other value? So it's 1 comma 1.
16.
Are you sure?
Oh, 1 over 8.
Yeah, there you go. Excellent. And let's put it on our graph. 1 over 8, guys, as a decimal is what? Approximately. 1/8.
0.125.
Yeah, so it's really close here. Okay, do you guys want to do first derivative test or second derivative test? Do you want to try first derivative test for this one? Yeah? Okay, so for this one, we'll do it now. We'll do first derivative. Just to see the difference. Okay, so that was 3. Now I've got my first derivative test. I've only got one value to test, which is good. And my factors, where are my factors? So negative x plus 1 and then x plus 3. All right. So at 0, what do I get there? Positive or negative? If I were to sub in 0, what do I get there? Positive.
Positive.
Positive. What about here?
Positive.
Yep. So overall it's
Positive.
good. And now to the right of 1. So if I were to have 2 here, now what's happening? It would be negative. Yeah. And then here?
Positive.
Good. So do we see a change in concavity? Or sorry, do we see a change in the slope? We're going from increasing to decreasing. So what do we conclude? So it's a maximum. Good. There's a maximum, yes. Yes. If it was squared, it's not as important because it will always be positive, but it should be negative, right? But I say always included, just to be safe, right? Okay, that's my first derivative test. So now what do I do next? I find my second derivative. So I can't see my first derivative, so I'm going to have to rely on you guys. So I think I started using this. So, second derivative, guys. Who's going to do it for me? Let me just do this so I can see it. Who's going to do it for me? Anyone? Someone at
X
home?
plus 3 all squared times negative 1
Yeah,
minus negative x plus 1 times 3 times x plus 3 squared.
okay,
Divided by x plus 3 to the power 6.
good, 3 times 2. Excellent, okay. Okay, from here, can I factor? What are my common factors
Plus
here?
3 and
Yeah,
negative
how
1,
many of them?
2.
Good, 2 of them. And then I'm left with negative 1. What else? How's that? And now using my exponent laws. Uh-oh, yes, you're right. I missed one of them, didn't I? I took them all away. Let's fix that. I have one more here. I've got 2 of them, I've got one more here. So here I've got negative x plus 3, and then I have minus 3. There we go. Yeah? It's done. Yeah. Yeah. Oh, I see what you're saying. No, I see what you're saying. Yes, I see what you're saying. What happened here? Why did that happen? Oh my gosh, guys, why did this happen? I know exactly why this happened. Guys, look at our first derivative test. What did we forget to put in? And I'm so happy that this happened, because now you can see how it messes you up. What's missing in that first derivative test? Yes, you have to put in the vertical asymptote. There is a break in our function. You have to show that here, and that's why it's messing us up. If you look here, I have that it's the first derivative is positive, but it's not always, because what about to the left of that asymptote? There's a break. So we have to put that in. Oh my goodness, I'm so happy that happened. There, look. This emphasizes how important it is. Okay, ready? So I have to put my vertical asymptote in my first derivative test. It is crucial. And then I forgot my other value that you want. Okay, so now everything stays the same here. So here I have positive. Here I have negative. But now, to the left of negative 3, if I put in negative 4, what happens here? And if I put in negative 4 here, what happens here? Good.
Miss,
Negative 4 plus 3 is negative 1, and negative 1 cubed is negative. What's wrong? Yes, talk to me.
do we also have to put the 0 into the sign chart?
The 0, no. The 0 you don't need to. The 0
Okay,
is a
thank
regular
you.
part of your graph. You don't
Wait,
need
miss. For negative 4 times negative 1, isn't that just 4? 4 plus 1 is positive.
Sorry, where am I looking? For this one? Here?
Yeah, for negative x plus 1.
Oh, negative x plus 1. I apologize. Negative 4 plus 1. Oh, negative 4. Thank you. Yes, sir. Yes, sir. Yes, sir. Very good. I thought you meant this one, maybe. There you go. Good. There we go. We got it. Okay, let's continue over here. What do we get here? In my denominator, I have 6 minus 2.
Miss, why did it just change from positive to negative?
Because we didn't take into consideration the vertical asymptote. There's a vertical asymptote there. So there's a break in our function. So if it's positive, it has a positive slope to the right of -3, but to the left of -3, it could be doing something different. And in fact, it is. It has a negative slope to the left of -3.
Oh, okay. Thank you.
Cool. But there's no minimum there, eh? That's a vertical asymptote. So there's no minimum there. So be careful. This is VA. So there's no minimum there. But it must be in your sign chart, otherwise it messes you up, right? Good. Excellent. Okay, over here. So I have -x minus 3 plus 3x minus 3. What does this clean up to be? And then what do I do next? And we set it equal to 0. And so from here I see that. And that's our possible POI. And we know that it's the point 0, 0, right? It came out in our, is it actually, is it 0, 0? It's not. It didn't come out in our intercepts. What is it? 0, 0,
Miss, I think it's 3 comma something.
Yeah.
Oh my God, I'm sorry. It's Friday. Misty's losing her mind. Woo. So 3 comma. There you go. Of course it is. X equals 3. So 3 comma. What is it? I just need some coffee. Okay, 3 comma.
1/9.
Beautiful. Thank you. So 3 comma 1/9. It is. Everything is so small. You're right. So 3 comma 1/9. I think we already saw 1/9. What was it? 0 point? You got it. That should be the same like my other point. I'm sorry, guys, on the smartboard, it's hard. Okay. And we found that there was a maximum at 1, yes? It's a little maximum, but it's still a maximum. Yes. So here is my point of inflection, yes. So it's going to be changing from concave down to concave up. All right, so now, last thing, let's talk end behavior.
Miss, don't we have to confirm if the point
Yeah.
of inflection is
Yeah.
actually?
So here I have second derivative. Here I have my possible POI. Let's confirm that it's a POI by doing our table. So this is the original function. Mhm. Because you were doing 3 plus 3 is 9. Yeah, it's okay. It's okay. Listen, I don't know. It seems to be that kind of day. Okay, so in this chart, we have our vertical asymptote. Don't forget it. And that's at -3. And then we have our points of inflection, possible points of inflection at 3. Put in your factors. So my factors are 2x minus 3. You don't really need the 2 there. If it was a negative, you do. You don't really need this here either because it's to the exponent 4. You know it's always positive. But I want you guys to include it. And the reason is I'm marking you. If I don't know if you're forgetting it or if you just know it doesn't belong to it. So please always just include it. Okay? Did everyone catch that? Always include it. I know it's not needed, but I want to know that you didn't just forget it, right? So make sure that you put it in. Okay, so to the left of negative 3, subbing in, what do I get? Negative. Good. Here, always positive. 0.
Negative.
Okay, and 4. Negative. So, here I have concave down, concave down, concave up. So where's is 3 a point of inflection? Yes, it is. Yeah, where? You're good? Okay, now, end behavior. Right, we've got everything. Let's state our hills and valleys. So, what do I have? So basically, when am I, let's talk concavity. Let's say concave up and concave down. So we're concave up when x is greater than 3, and we're concave down when x is less than 3. Here, I would accept x is less than 3. There is a break in our function, so technically you should say x is between negative 3 and 3, and then again, x is less than 3. Because we have a vertical axis with it, but I will accept x is less than 3. Okay? Yeah, you can use that format, sure. Just use it properly. Make sure that the square brackets are linear including, the round brackets are linear not. Okay? Okay, good. So what's left? Last step. Yeah, I stopped listening. Bye. Okay, as x approaches positive infinity, what's happening to y? So we can just, it's as easy as subbing in a very big number.
It approaches 0 from above, I think.
Okay, but hold on, we're talking about x. Oh, yes, y, excuse me, yes. So y is approaching 0 from above, you're absolutely right. And as x approaches negative infinity, from below, right? As x approaches negative infinity, y is still approaching 0, but from below. Yes? What? Yes? Yes? Okay, good. Is everyone okay okay with how we got this? Just sub in a very big value of x, sub in a very small value of x, see if you're above 0, if you're below 0. Okay? Cool?
Miss.
Yeah.
So we don't have to state the end behavior as x approaches the asymptotes.
As x approaches the asymptote? No, because that's not the end.
Okay, thank you.
We're just talking about the ends. You want to know what's happening at the end. The reason that you do this normally, guys, and this is why I really don't usually include it. The reason you do this is because graphs cross. Sometimes, at very far away from the origin, they'll cross from below an asymptote to above. And that's usually why you do the end behavior. But you guys don't see any of those stuff. So it doesn't really affect you. But it's good to understand how to do this. So it's just like, it's good to do it. Okay, so let's graph everything now. So we have everything. So what's happening here? Well, we know that we are, what did we say? Concave down. When we are, what was our concavity? Less than 3? So for all of this, we're concave down. Now, we have a point of inflection, so it's going to be easier for you guys to use your pencil. What I want you to do is now change this to concave up. So here we're concave down, change it to concave up. You're concave down, and now you're concave up. Okay, just make sure this is not going up towards, it still has to be approaching 0, right? Just be careful. Let's try it again. So you've got this maximum, and then you're changing concavity. Okay, so show me a little change in your concavity. Okay, now, to the left of the asymptote, we know that we're concave down. The fact that we're concave down, obviously, we have to be below the asymptote. Yes, and we saw that in our end behavior as well. I don't want you to just randomly draw something here. What I would like you to do is find a point, right, so that we can be more accurate. So sub in -4. If you sub in -4, what value do you get?
-3.
So now you have some direction. So when you go to graph this, you have a little bit of direction. So -4, -3. We know that it follows the asymptotes, and we know that it's concave down. I'm sorry? In the middle here, yes. Yes, it does. And we saw that in the lesson as well, yes? So in the middle here, yes, it does.
Miss,
Yeah.
so how do you know the left side doesn't cross the horizontal asymptote like the right side does?
Sub in a value. Sub in a value very, 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 very small. So sub in like, I don't know, -1,000. And are you positive or are you negative?
Positive.
Are you below 0 or are you above 0?
Oh wait, no. Wait.
Yeah, you're below 0. So that's how you know that it doesn't cross.
Okay.
Yeah.
Miss,
Yeah.
for the end behaviors, when you say to sub in like a really large number, really small number,
Yeah.
where do you sub that into?
Always the original. Because you're talking about the graph, like points on the graph, so always the original function.
Oh, okay, thank you.
Yeah, no problem. Okay. How's that? Are you guys okay?
Yep.
Okay. Thank you. Is that Mikhail? All right.
Yeah, Mikhail.
Thank you. All right. So this is good. You guys have an extra worksheet to do as well as this homework. Okay? So you guys can work on that. until the end of the period. If you have any questions, I'm here, okay? I will also assign the review for you guys, okay? Please look at the special notes here, guys. You can't factor G double prime of X is on page 213 of the 4H. 4I is a slant asymptote. Again, guys, how do you know when it's a slant asymptote? Look at the degrees, right? It's always one bigger, 1 degree bigger in your numerator. Okay, and then 4J is a cup. Okay, so just to sort of help you out there.
On this.
Yeah,
I know. I think I asked this yesterday, but I kind of forgot. So, can price or people ever be zero for those revenue questions?
yeah, they can. Oh,
They
price.
can?
No, price cannot be zero.
Okay.
Who can be though? Like nobody could go to a party, sure. Nobody could attend.
Okay, but price still can't be free. So it has to be greater. It has to cost something.
Yeah, it's gotta cost something, right?
Okay. And this, can you do a textbook question?
Can I do A?
Textbook question?
Of course I can. Which one?
Number 10 from 4.1. Page 171.
Do we need to know how to calculate slant asymptotes?
Sorry, say it again.
Do we need to know how to calculate slant asymptotes?
No, you don't. You're not gonna be given any slant asymptote. No, you won't be given cusps either. Okay, so hold on, 4.1. Number 10. So use the derivative to show that the graph of the quadratic function f of x equals f, where a is greater than 0, is decreasing on this interval. So you need to find your first derivative, which in this case would be 2af plus b. And then you set it equal to 0 to find your critical point, which is how you get your negative b over 2a. And then you want to check to the left and to the right. And what they're telling you is that a is greater than 0. So if a is greater than 0, then this value is always negative.
Yeah, I did that. I did an interval chart, and I did negative b over 2a minus 1, and then negative b over 2a plus 1, and I still got it's decreasing at first and increasing. And I know you can solve it just by using logic, since if a is greater than 0, then it opens up. But I don't really know how to explain that in the interval chart.
In an interval chart?
Yeah,
Okay.
because it doesn't
Yeah.
matter if a is positive or negative. You can get the same answer. I don't know.
Well, what you're seeing here is a is always positive. So if a is always positive, then you know that this value is negative. So, you use 1 as your bound, you used 1 as your bound, is that what you did?
Oh, for the interval chart, I did negative b over 2a minus 1 for the left, and then the right is negative b over 2a plus 1.
Oh, right. Because you take, hold on, let me do it. So what I would do, one way that you could do this, I don't know if I would want to do it. There's no restriction on B, right? You just know that X is greater than. You can only do it by analysis. So by the way that you did it, by using the fact that this is a parabola, A is greater than 0, so you know that it opens up, and then you would analyze it from there.
Okay, so you just say since it's positive, it always opens up, regardless of what B and C equals. Okay, thank you.
Yeah.